Welcome back. This is Nick Agram once again. The next topic that I'm going to discuss is about linear inequalities in two variables. Maybe you are familiar with these symbols. And this symbol, and that symbol, there's another symbol. If I'm going to read this is the greater than, less than, greater than or equal, less than or equal. What's the difference between these four symbols? When we talk about greater than, for example, we have x is greater than 5. Let's say greater than 3. But less than or equal to 9. That means we have from 3 to 9. But you can see I put less than a greater than there, but here is greater than or equal. What's that mean? That means that my interval is from 3 to 9. From 3 to 9, as you can see here. But the difference is that I'm going to put a circle there, but here it is a point, a short point. Why? It doesn't like that. A solid one, a circle, but it's solid one. In 3, it is not solid, or there's just a circle. Why? Because it indicates that 3 is not included in the interval, but 9 is. That's the difference. So when we have just the greater than or just the less than, then the number is not included. But if we have the greater than or equal or less than or equal, then we are talking that both or the number itself is included. So if we have this expression, x is less than 0, for example, that means 0 is not included and everything here is included. But if we have x is greater than or equal to 0, I will just erase that so that then we are talking about zero here, but it is the 0 is part of the interval or part of the expression. So it's 3 as from 0. 0 is included. And yeah, when we are talking about two variables, that is for y, I just want you to see. But when we are talking about two variables, for example, we have y is equal to x plus 4, for example. When we graph that, it will look like this. It will look like that. But if we have y is less than x plus 4, as you can see here, remove that, less than x plus 4. Then you can see here that we're talking about the line itself, but the area that we're talking about now is the whole area under the line when we talk about less than. And as you can see here, the line is a broken line. Why? That indicates that the line itself is not included in the solution. Let's see if we can see with less than or equal. This is now is less than or equal. We're talking about the same area under the line, but the line now is solid. That means the line itself or the points in the line, on the line, are included in the solution. The same is true when we're talking about greater than. Y is greater than x plus 4. Then we're talking about the area above the line. But because if it is greater than, then we are talking about a broken line. So remember that when you do your lines, you need to remember if you're talking about broken lines or solid lines. So when we're talking about just greater than or less than, then we are talking about broken lines. Greater than is always above the line. Less than is always below the line. The only difference now, if we're talking about less than or equal, we're talking about the same area, but the lines are included. So the lines are included even here. Let's see if we can do more. I have written another example here. 3y is greater than 4x minus 6. So if we divide both sides of the equation by 3, then we have only y now is greater than 4/3 x minus 2. The line of this is a broken line. That is, it's greater, that means that is above the line. So if we're going to write the equation now, y is greater than 4x minus 6. So as you can see here now, the line is, or the solution is above the line because it is greater, but your line is broken line. Another example, y is less than or equal to 3x minus 1. As you can see, it's less than or equal. That means my line is a solid line, and my shades or the solutions is the area under the line, and the line is included. But if you don't have this GeoGebra, how do you do it? By hand. That is what I'm going to remind you now. I think we did this before. What you can do is create a table first. So for example, you have x is equal to 0. Then we have minus 1. X is equal to 1. Then we have 2. I hope you understand now. 3 times 0 is negative 1. 3 times 1 is 3, minus 1 is 2. Then if we have 2, then we have 6 minus 1, and we have 5. It will disappear. 5. It's enough for those 3. Then you can plot that in your in your coordinate system. I need to do something first. We have what we got: 0, -1, 1, 2, 2, 5. So we have 0, -1. It's here. Here is my point. I didn't get my point there. There you go. And then 1, that's 2. 1, that's 2. There you go. And then 2, 5. If I'm going to connect the points or the dots with a line, and the points that we're talking about is, or the solutions that we're talking about are all the points under the line. So I don't know if I can use all the points here, or this area are part. This area is part of your solution. Sorry for the grammar. So I hope you learned something about inequalities in two variables. So what I am discussing now: linear inequalities in two variables. In my next video, I will be discussing systems of linear equations. I will be discussing graphical solutions, and I will be discussing also algebraic solutions, substitution and elimination. So I hope you will be there watching my lectures. I hope to see you soon. Bye.